Jai Hind everyone, my name is Aastha Sharma from CSE department at Ajay Kumar Garg Engineering College and my subject is operating system. And today I will talk about the disk scheduling algorithm and the RAID levels used in the operating system. So as you can see that disk storage, what is disk storage? It is divided into some type of tracks which can be divided in A, B, C and D. A is denotes to the track which is in the hard drives and B is the sectors and the C is also some type of the sectors of the track and D is the cluster formation in the operating system. So disk storage, it is used in the read and write head positions just used in the disk surface, and the information which is stored by the magnetic recording on the track under the read and write operation in the operating system. It has the some type of the fixed head disk, it also moving head disk, and it also designed for the large amount of storage which is used in the primary design consideration in operating system. So as you can see, this is the architecture regarding the hardware of the for the disk system, which has some type of the operation. It can read, it can write, it can devise, and it can also associated with the logics also. And the disk controller, it is some type of the logical integration with the computer systems, and it can has the some type of the services which is more than the one drive overlapped seeks value. Then the cylindrical value, if I'm talking about the same number of the tracks on the disk surfaces, and it has some type of around 8 to 32 sectors contains each tracks. Then sectors, which is a sector, it is some type of the smallest unit of information which holds, and that can denote as a read and write into the disk operations, and it has some type of the range between the 32 to 4096 bytes. So the data in the disk storage is specified by the surfaces, the tracks, the sectors was there, and all these are the three dimensions arrays of the sectors. Operating system treats the disk as one of the dimensional array of the disk, which can be blocks and divided and subtracted by the number of the sectors per tracks. Here you can see like the B equal to, right, the B equal to K plus S into J I into T. So the T defines the number of the tracks per surfaces, and the B denotes the disk address of the particular sectors, and it also defines the cylindrical tracks or the cylindrical sectors in the form of the J. Right. Next, if I'm talking about the disk scheduling algorithm, right? What is disk scheduling? Disk scheduling, it is one of the important factors in the operating system which is used to schedule the input-output request arriving for the disk. It also known as the input-output scheduling in the operating system. So the multiple operations in input-output request may arrive at the different processes, and only one process of the input-output request can be served at a time by the disk controller. And this input output request needs to wait for authenticating the process, and then this process can schedule in the CPU and it give you the output, right? Next is the two or more requests may be far from each other, and it can result in the greater disk arm movement, and some of the hard drives are one of the slowest part of the operating computer system, and thus it needs to be the access in an efficient manner. So there are many disk scheduling algorithm are used in the operating system. Number one, here are the some type of the terms which is used in the disk scheduling operating system. Number one is the seek time. Seek time, it is the time which is can taken to locate the disk arm to a specific some type of the tracks where the data is to be read or write. So the disk scheduling algorithm arrive at a minimum average seek time, which is the better time. Next one is the rotational latency. Rotational latency, it is the time taken by the desired sector of the disk to rotate into the positional so that it can access the read and write heads, and so the disk scheduling algorithm give you the minimum rate of latency area. Next is the transfer time. Transfer time, it is the time which is used to transfer the data, which depends on the rotating, right, the rotating speed of the disk, and the number of the bytes can be transferred in the operating system. Next is the disk access time. Disk access times can be calculated by the seek time plus rotational latency plus the transfer time. All these can be concluded by the and give you the output of the disk access time, right? Next, let's talk about the number one scheduling algorithm, disk, which is FCFS, which is first come first service. As you can also read about the FCFS algorithm in CPU scheduling algorithm, which can be taken by the arrival time. At that time the CPU can take in the arrival time, right? We can see the arrival time in the first come first service CPU scheduling algorithm. And in the disk scheduling, it is the very simplest form of the scheduling algorithm, where the requests are addressed in order they arrive in the disk queue. So the major advantage of the FCFS disk scheduling algorithm, every request get a fair chance. So first come first service allowed. Next is no indefinite postponements, like, okay. Next is the disadvantage, does not try to optimize the seek time. They can take their own time to execute and give you the output, right? May not provide the best possible services. It may not provide you the best possible services, but it can provide you the services, right? Next, as you can see, here are the some examples. Some type of the disk sequence was there, and we have also given the 100 tracks. So if you want to calculate the range, the graph of the 100 tracks, it can be calculated by the 0 to 99 tracks was there at the type when you draw the graph, right? Next is few elements was there, right? Disk sequence was there. Next, we have the sum. We also given the question the starting point. The starting point of the head is 50, and we need to move in a left direction. And here we need to find out some type like the head movements in the cylindrical FCFS. We need to calculate this. So first, when you see this type of the questions in FCFS, first you need to calculate the range. Next, you see the sequence of the elements. Next, third step is you need to see the head point. Starting point is which type of element can be started. As you can see, the head element is the 50, right? So at the 50, we need to see started from the left side, right? So left side, which element was present? 45. Next is, and we need to move on the left side, the 21 present, and then the 21 nearest element, which element is present? 67. So in this first come first service, we need to find out the nearest element, right? We need to start it, as it mentioned in the question, we need to start it from the left side, and then after that we need to search the bestest element, like best closest element during this making preparation, right? Next, 67, so closest element is 90. Next, we have the closest element is 4. Next is 50, 89. Next, 52, 61 and 87, right? So how you can calculate the head movement, right, in FCFS algorithm? First, we need to started the head is in the 50. After that, from 52 we go from 45, so we minus 45 plus, right, 45 to 21 minus subtracted, then plus 67 to 21 minus, then plus 67 minus 90, add 90 minus 4 plus 50 minus 4 plus then 50 minus 89. So you can go from like this further and you can calculate it, the number of heads in the FCFS scheduling algorithm. Next is SSTF, which is the shortest seek time first, right? In CPU scheduling algorithm, we have the shortest job first, yani the minimum time of the what type of process arrived at the minimum time, right, which has the minimum burst time, we can execute it that process at a one time, right? So in shortest seek time first, the request having the shortest can be executed first, which has the shortest time, seek time, it can be executed first, right? So the seek time of the every request is calculated in advance in the queue, and they can be scheduled according to their calculated seek time. As a result, the requested near the disk arm, it can be executed first, and it can also decreases the average response time and the average throughput of the operating system. Advantage is like it can decrease the time, it can give you the throughput increases, right? Decrease the time, but it can increases the throughput. Disadvantage is like overhead to calculate the seek time in advance, and it can give you the starvation period as comparison to the incoming request, right? As you can see, the questions is like, consider the disk request, we having the track is 100, so the range of this track is 0 to 99, right? 0 to 99, you need to calculate this 0 to 99. Next we have the sequence of the disk, right? And the starting point is 50. For example, you need to calculate like this. First mention all the elements, right? First mention all the elements, then we have started at the 50, right? Starting point is at the 50. After that, we need to search the closest element of the 50. The closest element we have the 45 and 52, which has the slowest, like which has the closest or the shortest seek time, we have the 45. So we move to 45, right? After 45, which element has the closest seek time? We have 52. Then again, after 52, we have the closest seek time is 61. Then after 61, we have 67. After 67, we have 87. 87, we have 89. 89 to have, we have 90. And 90 to we move from the left side again, right, to cover all the elements, right? We have the 25, next we have the 21, and then we have the 4 elements. So how you can calculate it all these? Just you need to subtract it from 50 minus 45 plus 45 minus 52 plus 52 minus 61 plus 61 minus 67 plus 67 plus minus 87 plus 87 minus 89 plus 89 minus 90 plus 90 minus 25 plus 25 minus 21 plus 21 minus 4. So you can calculate it like this, the number of the heads movements in the SSJF, right? Next, you can see the scan dish. So in this, you need to scan all the elements, right? As you can see, it is also called the elevator algorithm. Like in this algorithm, the disk arm moves into a particular direction till the end, and it also satisfying all the requests coming in its the path, and it turns back end and moves in the reverse direction, satisfying the request coming into its parts, right? The advantage is it can give you the high throughput also. Then it also give you the low variance of the response time. It can also average the response time. The disadvantage is, the major factor of disadvantage, it can give you the long waiting time period of the particular process to execute in the disk scheduling algorithm, right? As you can see, we have the number of the tracks. Number of the tracks can be ranged into the 100, 0 to 99, right? 100 tracks. After that, few elements was present. Next, we have the starting point is, we have the 54, and in which direction you need to move, as it's mentioned in the question, like left direction you need to move. So at the 54 we need to move. So the closest element of the 54 we have 14. Again, the closest element of the 14 we have no one. So we need to go to the 0 value and then move to the next element, right? We need to cover up all the elements, like you need to scan all the elements, right? You need to keep track all the ranges as it is mentioned in the disk, right? Next, 0 to 65, 65 to 78, 78 to 98, 98 to 122, 122 to 133, 133 to 137, and then 183. And the number of heads can be calculated by this, by subtracting the adjacent elements and adding the value, right? Next we have CSCAN, right? CSCAN, disk scheduling, which means is in the scan algorithm, the disk arm, like again scans the path, and that can be scanned, and after reversing its direction. So they need to, in a scan algorithm, they need to cover up all the elements which is mentioned in the tracks, right? So it can be possible that too many requests are waiting at the same time, and it may be also the 0, or the few requests is pending in the scanned area, right? So this situation needs to be avoided with the help of the CSCAN algorithm, which means instead of reversing the direction, we just move backward from that element which is the closest element was there in the graph, right? So it starts servicing the request from there. So the disk arm moves in a circular fashions, and its algorithm is kind of similar to the scan algorithm, and it called called the CSCAN scheduling algorithm. The advantage is like it can provide you the uniform wait time compared to the scan algorithm. So as you can see, we have the number of tracks is 100, the ranges between the 0 to 99. After the element was present, we need to start it from the 54. In which direction? The left, right. Same question as you solved in the scan scheduling algorithm, right? So in 54 we need move forward to the 14, then again 0, then again we move forward, not to go just to adjacent element, we go move forward to the 99, right? 199 or 99 ranges, right? And then we need to cover up all the elements present in the graphs, right? Number of the disk was present. So it can be calculated by dividing the each by subtracting the adjacent element and adding the all elements, right? Next, we have look scheduling algorithm. In look scheduling algorithm, some type of the extent or expect the difference that in this the moving inward, like where no more request in the direction exists. So it tries to overcome the overhead of this scan algorithm, which can force the disk to move in a one direction, and in regardless knowing if the any request exists in the direction or not. So as you can see, the number of the tracks was present. Is 100, or it can be, question is wrong, not 100, it is 200, right? So 200, so range is 0 to 199, right? The number of the elements was present and starting at the 54, and which direction? Left direction is moving. Then let's start with 54. The closest element of the 54 in the left direction is 14. After that, in 14 we need to move on the rightwards, because in left direction we have no elements was present. So we 14 to the closest element, we have the 65. Next we have the 78. Next we have the 98, 122, 133. Next 137 and 183. So how you can calculate it? The number of the heads, 54 minus 14, right? Plus 14 minus 65, right? 14 minus 65, then plus 65 minus 78, 78 minus 98, plus 98 minus 122, plus 122 minus 133, 133 plus 133 minus 137, plus 137 minus 183, plus 183 minus 199, and you can calculate it. The number of the heads in the disk scheduling, like look scheduling algorithm, is 209. Right. Next, we have the CLOOK scheduling. CLOOK scheduling is kind of the similar to the CSCAN scheduling algorithm, and in this, the disk was moved outward servicing request until it reaches to the highest request cylinder, and it jumps to the lowest request cylinder without servicing any type of the request and moving to the outward direction request. So in CSCAN, we need to move till the last cylinder, last track of cylinder, regardless of knowing whether it requests to be serviced or not. So as you can see, the example we have, again we have the 200 tracks, not 100, it is 200, which range between 0 to 199. The number of the elements was present in the disk, then the starting point is 54, and we need to move from the left direction, right? Next, not in left, it can be moved in any direction, right? So we can take the 54. Starting 54, the closest element was present is 65. Then next 65 to 78, 78 to 98, 98 to 122, 133, 137, 185, 183, and then we don't need to go to the 199, right? We just need to scan and look, right? Scan and look, we need to move forward to the backward, in which the left direction, which is the 14 element, and the number of the heads is 298 by subtracting the adjacent element and adding all the elements, right? Next, let's talk about the RAID, which is the next topic is the RAID, which is the redundant array of independent disk. It is the technique which is used to the combination of the multiple disk instead of using the single disk for increasing the performance, for increasing the flexibility, right? The data redundancy or both, right? So it can be taken, and it can be coined by the David Patterson, which is given the redundancy word, right? Redundancy, it is the type of the extra space which adds to the disk reliability talks about, and it also case of the disk failure, which can the same data can be backup into the another disk, and it can retrieve the data and can go on to the operations, right? So there are the some key points we need to remember by performing any operations in the RAID system, which is the reliability and the availability, right? Next, let's see the different levels in the RAID. So we have level 0, level 1, level 2, level 3, level 4, level 5 and level 6. So the level 0, the category of the level 0 is the stripping, which is the description which is non-redundant, right? In this lower the single disk, it can give you the large amount of the input output transfer, but it can also request very high for the read and write operations. If I am talking about the level 1 we call the mirrored, right? Mirrored RAID levels, right? In this the RAID higher than the 2 and 3, 4. Let's talk about the further RAID levels. It is much higher than the level 1, and it can give you up the twice single disk read and write similar operations, right? Level 3 is RAID level 3 is right the redundant via the Hamming code. In this we use the Hamming code, which is the highest of all the listed alternatives levels. Next we have level 3, which is the bit interleaved parity, which means it gives you the highest all list of the alternatives, and it can approximately give you the twice of the single disk. Next we have the level 4, which is the block interleaved parity, which means it can kind of similar to the RAID 0 and for the read and write operation, and it give you the significant lower value of the single disk for the write operation. Next is the RAID 5 level, which is the block interleaved distributed parity, which is similar to the RAID 0 for read and generally lower than the single disk for the write operations. Next is the RAID level 6, which is the block interleaved dual distributed parity, which is the highest of all the listed alternatives, and it is kind of similar to the RAID 0 for the read is significantly lower than the RAID 5 for the write operations, right? Let's talk about the RAID level 0, which is the stripping. In this you can see the blocks of the strips can be divided into the disk value. So the blocks which is 0, 1, 2 and 3 form the strips. Instead of placing just one block into the disk, we can work on 2 or more blocks placed at the disk next to the one. So as you can see, they placed the reliability. We need to check in this the reliability and the capability. The reliability is that we can check the no duplication was required, and it can also the capacity can be used by using the store data value. So the 0, the disk value is 0. Next within disk 1 we need to go from to the disk 3, then disk 4, then disk 5, 6, then next was updated by the disk 4, right? The selected elements which need to be arranged like that, right? Next we have RAID level 2, which is the bit level of a stripping. Like in this we need take the all disk in the bit level of the stripping. Instead of stripping the blocks across the disk, it is strips the bits across the disk, right? So all you need to do is the 2 groups of the disk, and one group can write and read the another operations, right? So it uses the Hamming code, right? It uses the Hamming code, and the Hamming code which is used to store the information in the redundancy disk, right? It can use the Hamming code which is used to store the information in redundancy disk. So when data is written into the disk, it can calculate the EEC disk, which is EEC code was calculated, and it strips the data into the some type of the data disk, right? Next, when the data is read from the disk, it can reads the corresponding EEC, right? ECC code it reads, and then from the redundancy disk, and it can check whether the data is consistent or not. It also uses the disk that can be configured in the many different types of the configuration, which is not valid, and this is not the used by the anyone, right? This is very expensive, and it can be implemented in the RAID controller in the complex, and to solve the different complex number of the problems we need to use RAID level 2 in operating system. Next we talk about RAID 3, which is use the byte level stripping. Instead of stripping the each block across the disk, we use the byte level, right? All data can be taken in the byte level forms, right? So it uses the multiple data disk disk and dedicated the disk to the store parity. So the disk have to spin in sync to get the data. Sequential read and write operation, which can give you the more flexibility, good performance in operating system. Random read and write operation can give you the worst performance in this RAID level 3, and this is not commonly used. It is used for the complex, to solve the complex problem. Next, we have RAID level 4, which is the block level stripping with dedicated parity. So instead of duplicating the data, it can adopt some kind of the parity based approach. So in this, you can see some type of the parity based approach was there. So the parities can be calculated by simple the XOR function. So if the data can be calculated by the 0001, so the parity bit of the XOR is calculated by the 1, which is the 001. So if the data of the bit 0110 parity, then can be give you the value of the XOR. So all these parity functions can be calculated in RAID level 4 is by using the XOR function, right? So as you can see in this, the level of the parity, right, we calculated the level of all the disk parity can give you the parity value 0, and this level of the parity value give you the 1, right? So it assumes that we can compute the data bit by using the value or in the column to the another parity bits to recover the lost data, right? Next, we have RAID level 5, which is the block level stripping with distributed parties, right? So it is slightly modification of the RAID level 4, which is where the only difference is the parity, which rotates among the drives. So it can give you the random read and write operation, which can give you the better flexibility, right? So if I want to check the reliability is 1, so RAID level 5 allow the recovery at most the one disk failure, and if more than one disk was failed, then it can recover to the data, and it can identify it to the RAID level 4, which has the capacity n-1 into B, right, which is hence the n-1 is the disk that can be made available for the data storage, and each data disk has the B value of the blocks. Next, we have RAID level 6. RAID level 6 is the block strip with 2 distributed parties, right? As you can see, we have the 2 distributed parties, each level of disk we have. So just like the RAID level 5, this does block level stripping, however it uses the dual parity. So in this, you can see the diagram of A, B and C, the parity 1, the parity 2, the parity 3, parity 4, parity 5 was there, right? So it can handle the 2 disk failure at the same time, and it can also recover and can give you the better flexibility optimization, right, in operating system. So the RAID configuration is complex to implement RAID controller, as it can be calculated by the 2 parity data for each data blocks. Thank you. Jai.